Hello, everyone. So this is the second sort of pre-lecture for week 2. And what we're focusing on, you can find the materials we'll be covering on the R. Davis page if you go to course materials. And we're today talking about how R thinks about data. So you can access it here. I'm actually going to pull up the same file, but in my R Studio window so that I can actually edit the code and run things in real time. This is sort of what a raw R Markdown file looks like that we then render and post as an HTML file on the web page. But the underlying content is all the same. And I believe you can actually access all this code as well. So the basic things that we're going to cover in brief in this lecture and then spend more time on working on in class is talking about the different data types that R uses. So the different ways that R stores things under the hood when you're naming and using objects. Talk about methods for one, sort of placing things together to make different types of different data types, and then also ways of looking at different objects that are already created or that you access from someone else to understand what type of data it already is. Talk about ways to change the data type from one type to another as needed, and then specifically talk about a unique type of data in R called factors. Factors are kind of complicated and sometimes quite crappy to work with, but also useful and important in other ways. So we'll spend a little bit more time on that, and then you'll practice in class. Okay, so we talk a little bit about why to use this stuff. I think in general, the overarching reason is that you simply have to understand how R stores data. Even if you're not planning on like writing a bunch of your own functions or becoming super well versed in R, ultimately, if you're a researcher, right, you have to have confidence in what is happening and what produced your results. And if you're not paying any attention to how R is storing the things you're programming and doing calculations with and reading in data and performing functions with, you are just more likely to make a variety of mistakes or have sort of wonky issues happen, right? So silly examples that it sounds like, well, that can't happen, but it happens to many of us all the time, right? You read in something that you think is numeric data and R accidentally thinks, not accidentally, because it is processing it in a certain way, R stores it as strings, and then you go to compute some sort of calculation on it, right? And it doesn't work because you've essentially like saved characters instead of numbers or that type of thing. And so understanding how and why R regards data in certain ways is useful for one, heading off those type of issues, and then two, diagnosing those issues and fixing them when they come up. So the primary way, the basic way R thinks about data is as vectors. And so a vector is simply a series of values. It can be just about anything. So I've shown a couple examples in the quick little video I filmed to recap some of lesson 1. But essentially, vectors are the building blocks for everything in R. So a simple vector might be something like these two numbers, 1 and 2 together. We've saved that as a vector. But a vector can also be aggregated into other things, right? And so you can make a list of vectors. A data frame can store a bunch of vectors as columns. Vectors are sort of the underlying building block in which everything else in R is based. And so it's sort of the core thing to understand. A vector doesn't have to be multiple values. If we just say 1, that's also a vector. So this is we'll call it a simple vector. This is just a vector of 1 value, but a vector can also be a whole bunch of different things. Not so simple vector. And we'll say this is two other string. So in this case, we're saying this vector is a couple numbers and some strings. Let's run that. And it's saying, hey, here's what's in this thing. Either way, it's just a vector. It's sort of a set of things you've tied together as an object. You maybe saw me use that C function to create the vector. C is a very simple but powerful function in R. The C is shorthand for concatenate. At least I believe that's the case. Did we say that in the lecture? I don't think we do, but I believe it is short for concatenate. And so simply what you're saying here is, hey, take these things and include them all as a vector together. If you don't call that, you're going to get an error. R is going to say, hey, I don't really know how to process that string because you put that bag of stuff in the parentheses, but you didn't tell me what to do with it. And so that C function says, hey, put all this stuff together in a vector. So we have some examples here in the Markdown document of different ways of creating a vector. So we have animals, we have weights, right? Numbers, letters, strings, whatever. You can combine them. The first and the simplest thing we can do with vectors, and let's actually make those objects so we can perform these things, is you can actually ask how long it is. So type in length. It says, hey, this is 4 things long. This vector is 4 things long. And if we add something, if we add a number up here, say this is 95, and then we run length on that object again, it's going to say, hey, this is actually 5 units long. If you want to learn more about length, we learned last week, you can call question mark length and hit enter, and it'll pull up the help object, the help document for that function. Okay. Another important feature of a vector is that ultimately all of the elements in it have to be the same class. And so this matters. You remember I created that weird vector. I might have deleted it, so I'll have to create another one again. If we call class on weight, it says, hey, these are all numbers. If we call class on the animals vector we created right here, it says, hey, these are all characters. So if we call something that is a bunch, so I said 1, 2, not a number, that's a vector. What do you think is going to happen? In this case, it looks like, because it's put those numbers in quotation marks, that it's actually converted everything to a string. So let's test that. We'll say new. Did that in the wrong box. Let's do it down here. And then, so new vector is that set of numbers in a string. Let's call class on my new vector. And now it's saying, hey, these are all characters. So basically the way to think about that is R sort of uses a lowest common denominator approach. So if it looks in and it sees all numbers, it says, hey, that's a number. If it looks in and it sees numbers and strings, it says the safest thing to do is to treat all these as strings. And that's actually important and valuable in this case, because if it tried to treat everything as numbers, this would break. And so if it says, hey, I see strings and numbers just to be safe, I'm going to keep it all as strings, you could always filter that out later or convert the numbers that are strings to actual numbers later if need be, but this is sort of the way of keeping that information lossless. Okay. One other useful thing to know is that calling str, and I actually don't recall what str stands for. Maybe it'll tell us in the help file. I think it's just short for structure. It just sort of shows you the structure of an object. So we'll call it on that weight vector. And so it's telling us a few things in shorthand here. It's saying this is a numeric vector. It is indexed from 1 to 5 units long, and here's what it looks like. That's not necessarily super important for a small vector. We can just type weight G, type it in, and actually we can see just about everything we need to know. But when you have much larger objects, so very large data frames, super large vectors, complex functions, all sorts of things, calling str on that object can be helpful because it can show you sort of like at the top level view of what's going on here, give you an overview of length, object type, things like that, without printing like 1,000 lines of code onto your screen. And so str is something to get used to now because you will need it later, because if you have like a million row database, simply typing in weight G and hitting enter, you're going to end up at the very bottom and not actually be able to see what's going on in that data frame. Okay, so a few other things. We can use C again on vectors to add vectors together. So we have weight G, we want to add something else. And so the original weight G is 5 units long. Let's add some things here. And so we've said, hey, concatenate the original weight G with these numbers to overwrite weight. And so now it is, has those extra numbers appended, it added those to the value. If you wanted to add it at the beginning instead, so in this case, we want to add 30 to the front end. So now if we look, we see 30 at the front with all the numbers we've added. You'll notice it keeps adding because we have overwritten the same object. So an important thing to note here is that if you don't rewrite the object, this appendage won't work. And so let's go ahead and make the original weight G again. I'm going to scroll up, hopefully not too dizzying. So let's just check, right? So the original weight G with those 5 values. So now if I delete this part and I just say, I want you to concatenate weight G with these 3 other numbers, it'll print that value to the screen and say, hey, this is what that new object will look like. But if I call weight G again, it's still that original object. I've not overwritten the original object. And some programming languages do this in different ways than others. And so that's an important thing to be aware of. So in this case, I have to actually assign that object again. Do that. I can, I spelled weight wrong, so now they're both going to be there. I'm going to retype that and Apparently I cannot type today. There we go. So weight G. So now if I call weight G, it's going to have the original 5 plus those other numbers, and they are all right there. Okay, cool. So make progress here. All right, so bouncing on a little bit in this material, we've talked about character values and numeric values. Those are examples of what in R are referred to as atomic vectors. They're called atomic vectors because they're the simplest data structure, right? So just like atoms are sort of like the simplest building blocks of matter. Can't keep my physics straight. I believe that's the case. In any case, these are sort of like the base types of structures in R. So along with characters and numeric values, the other ones you're likely to encounter on a fairly regular basis are logicals, which are Boolean data, so trues and falses, and integers. And integers, right, are pretty similar numbers, except it's a way of encoding where they have to be things like 1, 2, 3, 4, rather than numbers with decimal points. There are, you might periodically see something like complex or raw, but they're fairly rare, and I don't think they're probably worth our time to get into a whole lot. Important things to know, you can call type of on values, and it'll sort of dig down into what the actual type you're dealing with is. For the most part, a lot of these things don't come up, right? Typically, you're sort of using like some sort of numeric class or a Boolean true false class or some sort of character class. But there are certain cases where the doubles versus numeric versus integer, those types of things can be important. And so we'll come back to those at a later date. Okay, so I'm going to skip over the challenge and let you do all those on your own time. And we are actually going to move on to subsetting vectors. And so what that means is subsetting, or another word you might hear to refer to these sorts of things is indexing, is pulling values out of a vector, right? So you stored a bunch of things as some sort of object. It's only useful if you can actually get things back out of it. And sometimes you don't want the full thing, you want certain parts of it. So let's make this character vector, so this set of strings, and we can look at it. R says, hey, this is a bunch of characters. It's 4 units long. Its elements are mouse, rat, dog, cat. So let's say you want to pull the second one. So you can index in R. Anytime you're indexing something in R, you're going to use these square brackets, whether it's a data frame or a vector or a list or anything. We index the square brackets, and that essentially tells R, hey, I'm diving into this object and I want to pull a unit out from a particular area. And indexing can get kind of complicated when you're dealing with more complicated object structures, but when you are indexing or subsetting a vector, it's pretty straightforward. Whatever you're putting in simply corresponds to a location in that linear vector. And so if we want to pull out the second object, it's rat. We could actually save that again, and we could say rat, and now we have pulled it out, and it is simply a vector that has one unit, one entity that's part of it, and that is the string rat. You can call multiple indices at the same time. In this case, we're actually going to pull the third item and then the second item. And so now it is ordered that in terms of what was originally the third item dog and then the second item rat. You can also, and this is kind of interesting, you can call the same item twice. So if you say pull the third item twice, it's going to produce dog, dog. So there's functionally not a whole lot of limits on what you can do for indexing in that sense. I showed how you can create an object with more elements, right? If you call 3, 3, you get dog twice. So that's another example shown in the code. I mentioned last week about how R starts at 1, whereas others start at 0. So maybe Python, for instance. So in any case, we're on the same page about that. And you don't have to start with 0 in this case. The one important feature, and I mentioned this briefly last week in talking about when you're doing sort of data cleaning and conditional subsetting, is to know that you can subset with trues and falses as well. So for instance, we're creating this weight vector. Let's take a quick look at it. Those 5 units. If you say, I want you to sort this in terms of true, if you say a true, it's going to return it. If you say false, it won't. So if we call this value, it's going to return the items that correspond to the 3 trues. Now that seems silly in this case if you're saying, you know, I'm going to type out true and false for each one, but it becomes valuable if we want to do something like, I want you to return the values where it's greater than 30. And so now when I itemize that, what that essentially did is I compared every element in weight G to 30. I created a vector of trues and falses, and then I subsetted the original vector by that vector of trues and falses to produce these values. And that's another example that is shown here. We talked about briefly how you can use multiple conditions to subset. So again, in R, the ampersand is and, so both conditions have to be satisfied. And the big vertical line, I don't know what the actual term for that is called, is the or. So either of those conditions have to be satisfied. But nonetheless, so again, this stuff's pretty straightforward and simple on a vector, but ultimately this will become a very powerful way of subsetting and cleaning data. And being pretty well versed and well practiced, that is important because you got to get your cleaning and subsetting correct. Next element in terms of how R thinks about data, and I showed a quick example of this earlier, but just want to come back to it briefly, is how R approaches mathematical operations and ultimately other operations as well on vectors. And so in this case, if we create a vector that is units 1 through 10 altogether, that's what that the colon is you're telling R generate a sequence between 1 and 10. We could do it in reverse and make a sequence from 10 to 1. In any case, we're going to say the vector x is items 1 through 10. If we now say x plus 3, it's actually going to return a vector that is each of those items plus 3. Or same thing with multiplication. So it applies that operation to every item in the vector. Again, that seems fairly simple now. It's important to understand these things when we start dealing with like matrix algebra and other elements in terms of thinking about whether we're applying it to like every row or every unit, every column, or those types of things. In this case, that function is being applied, or that operation times 10 is being applied to every item in the vector. The general default is value to value math in R. And so that means that if you have, like in this case, x times 10, it's going to multiply each of those by 10. But if we did this, x times 1 times 10, it's going to say, oh, these are both 10 units long. And so we're going to take each one 1 to 1, 2 to 2, 3 to 3, that sort of thing. So what happens if we say x, which again is that unit, is that vector of values 1 through 10 times a 12 unit vector? And it's going to give us a big warning. And so what it's going to say here is, hey, we tried to guess at what you really wanted. So we started with 1 times 1, 2 times 2, and then we ran out. And so what we actually did for 11 and 12 was we started over on the first one and we started recycling. And so what we see here is this value is 11 times 1, and this value is 12 times 2. And so, right, this would really throw things off if you weren't if you hadn't been paying attention. So this is a good example of why warnings are worth paying attention to, is that the sort of value by value thing really threw us off in this case. The next element of vectors that's important to be aware of is missing data. So the basic way that R treats missing data is it represents it with the NA notation. And so NA shows up in lots of ways. Sometimes if we feed something into a function and it doesn't quite know how to process it, it might produce an NA. So for instance, in this case, what we have here is we're saying here's a vector of heights. We have 2, 4, 4, an NA value, and a 6. So if we try and take the mean of it, R is actually going to return NA because it couldn't compute the mean of 4 numbers and a missing value. So what we actually have to do here is we're going to use one of those extra inputs to the function. So calculate the mean of heights. And in this case, we want to remove any NAs. So we're going to say true. And actually, quick tip, you can use just a capital T or a capital F for true and false. So in this case, true. And so now it's going to compute the mean of just those 4 values and drop the NA. Probably the big thing is to recognize is often R has some sort of default for how it treats NAs. And so you want to get in the habit of checking for NAs first, so you're not accidentally just sort of coasting on with the defaults. And so a few ways of thinking about that. One I often use is simply using the isNA function on a value. And so if we call that here, it's going to give us a Boolean vector of whether or not each value is an NA. So what I often find on like a really large data set, if I have some really long vector, I might do something like this. Table is NA heights, and it's actually going to summarize how many trues and falses I get for that. And so it's saying you have one NA value and for non-NA values. I'll let you in lab will play around more with things like the complete cases function or the NA emit function, and we'll get some practice with that. So that's sort of a basic overview of vectors. You'll learn a lot more about those as we keep going. Now that we've talked about vectors, we can talk about the different elements that R assembles vectors into. So basically, there's sort of 5 different types of data structures we'll talk about in class. The first one are lists. So let's go ahead and dive right into that. Lists are maybe sort of like the most fundamental way R stores things because they're the most flexible. Sorry, not the most fundamental, the most, when you're aggregating beyond a single vector, a list is sort of the most fundamental way to treat multiple vectors because it doesn't say much about the structure. A list is just sort of like an arbitrary grab bag of vectors that have been appended to it. And so often lists show up where you have a bunch of different types of vectors. You could make a list where like the first entry is a data frame and the second entry is a vector and the third entry is a matrix. So lists are the most flexible kind of object for storing multiple things together in R. And so we'll come back to that and that'll make more sense when we get to practice with it. A data frame is exactly what it sounds like, and it's the one that's most similar to an Excel spreadsheet, right? So it's like as we say in the material here, it's sort of like a picky list where it's saying, hey, this is a set of vectors where they're all like the same length, and we're stacking them column by column to make something that looks sort of like a flat file spreadsheet. And so the elements of a data frame don't all have to be the same type. So you can have like one column of strings and one column of numbers, but they do have to have some sort of like rectangular structure, right? And so it has to be the one. And so it's a picky list because it can't tolerate a whole bunch of random things all jumbled together. It has to be a set of vectors that can aggregate into a rectangular data structure. Other elements to consider are matrices and arrays, and we're talking about those together because they're kind of the same thing in R. It's just it's 2D versus 3D. So a matrix, you're familiar with that. An array is just like matrices that are stacked on top of each other. And so rather than just a sort of like an X and Y location, there's also a Z location as well. These are typically the most bare bones, and we usually use them for storing numeric data. And you might get into matrices and arrays a lot if you are doing, doing some sort of complex algebraic functions or building some sort of mathematical, you're like writing a new algorithm to fit a model in a certain way. But we're probably not going to spend a whole lot of time on building things with matrices and arrays for now. The most important thing is just to remember that if you can sort of do indexing and if you can do, remember how vectors work, you'll have a good shot at handling matrices and arrays as well. Okay, and finally, we're going to talk a little bit about factors. So factors are a special type of vector, and they are a way to represent categorical data. So it'll look on the surface like strings, but it's actually a way of saying, hey, there are certain classes here, and maybe they even belong in a certain order. And so sometimes order matters, sometimes it doesn't. And to the extent that order does matter, that's often where factors come around. So let's make an example here. So we are creating a vector of sexes. So we're saying male, female, female, male, and then we're calling factor on that vector to say, hey, this is actually a factor vector. Now, if we call class on that object, it'll say, hey, this is actually a factor class object. We can use the type of function and it'll give us something that might not seem intuitive, right? So up here, we said class and it said it's factor. Now we're calling type of, and it says it's an integer. That seems confusing. So what's going on there? So fundamentally, what factors are is it's like integer values that are hiding under the hood. And so what you are saying to R is there's these classes, there's a 1, a 2, a 3, and a 4, and they correspond to something of this name. That have predefined values. And so it's like shorthand for we're going to code all 1s as females, all 2s as males. And so actually, if we say as numeric on that factor, it'll actually produce 2s and 1s. And the default is to go in alphabetical order if it's finding those string values there. It would actually do that if it started with a number in the string as well. So in this case, since our vector was male, female, female, male, the numbers are 2, 1, 1, 2 because F comes before M in the alphabet. So factors, probably the most important thing that we'll work on with factors in class is actually building the ability to move them around and shape them and re-level them. So you can imagine operations like you have some set of categories and you want to combine some, or you want to split some apart, or you want to reorder how the different factor orders for plotting. And so we'll get a lot of practice in those. At a fundamental level, you might ask questions like, well, what factor levels are there? So you call levels on the factor vector, and it'll show you the different levels. You might want the count of those levels. Obviously, there's multiple ways to achieve that. Like you can call length on the levels object, and it'll give you the same thing. We'll talk about ways to reorder. So like in this case, let's say you wanted to put male first instead of female. You already looked at those levels, and so you reproduce them in the order you want. And now if we ask to look at that object again, you can see that male comes before female. We can reverse that. And now let's try it one more time. And now we see it's reordered and female comes before male. And so fundamentally under the hood, right, are storing those as integers. It has names associated with it. I'm going to stop there because I think that's something we'll probably spend a bit of time practicing on in class. And just we'll practice, for instance, that you can convert factors to characters, all sorts of functions like that. So, but I think this video has probably gone on long enough. So with that, thank you, and look forward to seeing you all in class.